Welcome to 10 minutes CS. 9 to 1 minimum add to make parenthesis valid. A parenthesis string is valid if and only if it's an empty string. So we are given an empty string here, or it can be written as AB, such as A concatenated with B, where A and B are valid strings. So let's say this is A and this is B. So if we will concatenate it and make it like this, so this will also be counted as a valid string. Or we are given a string A, which is a valid string, and we add opening and closing parentheses surrounding it. So let's say this is A, so we can add some parentheses here and there to make it a valid string in total. We are given a parenthesis string S. In one move we can insert parentheses at any position of the string. Let's say we are given this, so we can add parentheses here, or maybe a closing parenthesis at the end. We have to return the minimum number of moves required to make S valid. Let's look at this example. We are given this, so we can add another opening parenthesis here to make it as valid. And for the other example, where we have 3 opening parentheses, we can add 3 closing parentheses at the end to make it as valid. So what are we supposed to return in the answer? Just the minimum number of moves. We are not supposed to return the output valid parenthesis string itself. Isn't this similar to the one that we did yesterday? I'll add the link to it in the eye icon, and it will be there in the description as well. Do check it out. So going up with the similar approach, where we have explained it in detail how we come up to the solution. So let's do a check on this string itself. We should eliminate all those strings which are valid in itself. Let's say this is valid, so we can just eliminate it and we are left with this one, and we can add a opening parenthesis to it to make it valid. So the number of strings which are left after excluding all those which are already valid, we have to include these many uh, opposite brackets to make it valid, correct? So but how will we eliminate the ones which are already valid? So going up with that same example, we can take a stack, and in stack, as we know, it's a leaf or data structure. So let's say we have added the opening parenthesis at the last, so we know that in the stack there will be no open parenthesis, and we can eliminate it with a closing parenthesis. So to approach it, we have to run a for loop over the string S, and let's say we have I pointer. Right now it's pointing to the 0th character. We see it's an opening parenthesis, so in stack we will only add those which are opening, so we don't need to uh, keep a check whether it's a opening or closing. So if our character C is a opening parenthesis, in this case we will just push it to our stack. So we added it here. Now our I has moved to the next one. Now it's a closing parenthesis, as we only have opening and closing, so we can use the else condition here. Now it's a closing parenthesis, and our stack is not empty, right? We can look at the check, so that we know that we have a opening parenthesis which can cancel it out. In this case we will just pop it from the stack and move to our next one. Now we again have a closing parenthesis, but we don't have any opening parenthesis. That means just a mismatch. So in the else condition, we can take a mismatch variable, we initialize it with 0, so the number of mismatch is added to it, right? Now can we just return mismatch in this case? Let's look at the another example, which is the other one. So we have now this as the example, which is we have 3 opening parentheses. Now we will again take a stack. Now we have an opening parenthesis, so we will add it according to our algorithm. We increment it to the next one, we will again add it and increment it, we will again add it and increment it. Now we are at the end of the string, but our mismatch count is still 0 in this case. So for this but the number of mismatches are not 0, so we have to add the mismatches when we have opening parenthesis. So this mismatch will actually count the number of mismatched closing parenthesis, and for opening parenthesis we know that the stack size will have all those parentheses, opening parentheses, which were not cancelled by the closing one. So we can, while returning, we should add mismatched, that will give us the count of the mismatched closing parenthesis plus the stack size. With this approach, we will have the time complexity of big O of n, as we have to traverse over the string where n is the length of the string, and the space complexity will be also big O of n, as we are using stack, and we see in the worst case where all are opening, so we have to add all of them to it. Can we improve on the space complexity? Yes, we know how to do it. We saw it in yesterday's problem as well. So instead of using a stack, what we are adding in it, we are just adding the opening parenthesis. So can we use just a variable such as opening parenthesis variable, or maybe a stack size variable? We will initialize it to 0, and each time we are seeing a close opening parenthesis, we will just increase our stack size, and whenever we need to pop it, we will just decrease our stack size. And to check if the stack is empty, we can check if the variable stack size is 0. So only when it's greater than 0, in that case we should reduce it. And finally we can return the stack size variable plus mismatched. Using this, we have optimized the space to big O of 1. Now let's look at the code for it. This is the exactly same code that we wrote earlier. So we have stack size 0. Now n is the length of the string. Mismatches, that is equivalent to the mismatched closing parenthesis, and this will be equivalent to mismatched opening parenthesis. Now we loop over our string. We check for the ith character. If it is opening parenthesis, then we increase the stack size. Otherwise we check if the stack size is greater than 0, then we decrease it. And otherwise, if the stack size is greater than is equal to 0, in that case it is a mismatch for the closing parenthesis. And finally we return the sum of the mismatched closing and opening parenthesis. Thank you for watching.